In this video, we have a look at some more midpoint theorem, and this time there will be more than one triangle in each sketch where the midpoint theorem can be used. Example 1. In the sketch, HK is equal to KI and HM is equal to ML, which is also equal to LJ. One length is also given, and that is that NL is 15 meters. The question here is to determine the length of Km. So we need to either be on the lookout for two sides of a triangle that have been halved so that we can use the midpoint theorem, or one side that has been halved by a line parallel to another side of the triangle to use the converse midpoint theorem. The line in question is formed from point K to point M, and that is why we are now going to focus on these 2 points. Point K is exactly in the middle of HI, and point M is in the middle of HL. That is why we can work in triangle HIL using the midpoint theorem. When there's more than one triangle in a sketch that you can use, it is important to write down in which one you are working. I'm going to start off writing down the if part. We know that HK is equal to KI, and we know that HM is equal to ML. Therefore, we can make the conclusion that KM is parallel to INL and that Km is also half the length of IL. And for this, our reason will be midpoint theorem. Our problem is that we don't know the length of IL. Therefore, we're going to move to a triangle where we have a length. We were given that NL is 15 meters. L is the midpoint of MJ, and N lies on the line KJ. Therefore, we can work in triangle KMJ. In this triangle, we already know that KM is parallel to NL, and we know that L is the midpoint of MJ. Therefore, we have the converse midpoint theorem. So, if we once again start by writing down what we know, our if part, we can say that Km is parallel to NL, and that comes from our previous theorem. And we know that ML is equal to LJ. Therefore, we can accept that Kn is equal to Nj, but the important part is that we can also say that Km will be twice the length of NL. This time my reason will be converse midpoint theorem because I had the parallel lines at the beginning. And of course we know that NL is 15 meters, so Km will be 30 meters. Example 2. In the sketch, AE is equal to EB, EF is parallel to BC, and FG is parallel to CD. So here you can see that in the triangle on the left, triangle ABC, we have enough information to use the converse midpoint theorem. In the triangle on the right, we do have parallel lines, but not yet enough information for a theorem. So even though the question is to prove that AG is equal to GD, I'm going to start working in the triangle on the left. In this triangle, we already know that AE is equal to EB, and we know that EF is parallel to BC. Therefore, we can make the conclusion that AF is equal to FC. This is because of the converse midpoint theorem. And because we now also know that AF is equal to FC, we can move to the triangle on the right and also make use of our converse midpoint theorem. Because here we now know that AF is equal to FC, and we were given that FG is parallel to CD. Therefore, AG will be equal to GD. And again, my reason will be converse midpoint theorem. From these two examples, it is now clear that you sometimes need to first work in one triangle and make a conclusion that you can use in a second triangle.